Alright, what we're going to do today is we're going to connect the Pythagorean Theorem to square roots and that into some sets of numbers for you. And, well, let's get started. So first thing I want you to know is how to read this. That's called the square root of 11. That's how you say it, square root of 11. Square root, it really refers to the shape of square where all the sides are the same. And in particular, they're talking about the area. The way you find the area of a square is you take one of the sides and multiply it by itself, which is called squaring it. Okay, and roots mean where does it start? Where does it come from? So we'll get into, I'll tie this in a little bit, but a square root's asking, if I know the area of a square, how long is each side? Where does it start from? That's what it means. Okay, what does the square root of 11 ask? What it really asks is, and another way to say it is, what number squared is 11? So the square root of 11, let's talk about the square root of 11. It asks what squared is 11? Okay, that's what it asks for. Now, a couple things you got to know about this 11 right here. This number inside the square root, that's called the radicand. Now, it's not separate. It's not like this is a shape and there's like just an 11 in there and you can separate them. No, this whole thing is all put together. So when I say, like, when I write something like this, okay, that's the square root of k, what it's really asking for is what squared, what number times itself equals this number right here. This is called the radicand. Okay, radicand. Okay, so square roots ask. So square roots ask, what squared is the radicand? Is the radicand. So for example, okay, for example, if I had something we all know, square root of 9, we know that's 3. The reason that's 3 is because this thing right here, this is asking us for, this thing is asking what number squared, excuse my abbreviation right there, what squared is 9. 9 is the radicand. It's the number inside the square root. This is asking what number times itself is 9. That's why it's equal to 3. Because 3 squared is 9. Right? So one more example of that. Square root of 64 is asking what number times itself equals 64. And it's equal to 8. And the reason why is because 8 squared is 64. They're opposites. They're like opposite operations. Square root's asking what number times itself equals 64. 8 squared is 64. That's why this is 8. The number times itself that's 64 is 8. That's why the square root of 64 is 8. Okay. Now, if I were to type in the square root of 11 on a calculator, like this one right here, let's see, I get 3.31662, blah, 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 blah. Actually, this number right here goes on forever. We could spend a lot of time talking about it. But literally, it goes on forever. It never stops. It never repeats. This decimal has no pattern. It's literally infinite. So if you were to assign a letter of the alphabet to numbers 1 through 26, your name would be in here. Every book ever written would be in here in order. So you could find, oh, I don't know, you could find the Harry Potter series, all of them written, if you translated these numbers into text, somewhere in there, because it's infinite. It never stops. So eventually you're going to find it if you can just look far enough. Alright, so the square root of 11, we can't actually write out what that number is, because it never ever stops. So we write this instead. This is the number times itself that equals 11. We can't actually write what it equals. This is an approximation. That's a decimal approximation. In fact, if you take 3.32, so let's see, 3.32, and if I square that, I do not get 11. I get something a little more, right? So, this is just an approximation. Or this is an approximation, that's exact. So we write this because it's exact. Now, we wouldn't leave, for example, earlier we were doing the square root of 9. We wouldn't leave it the square root of 9 because we know exactly what times itself equals 9. It's 3. So we can go ahead and write what that answer to this question is. But we really can't answer this question not by writing it out. So we just leave it like that. Okay, that leads us to this last topic, what are rational versus irrational numbers? This is irrational because you can't write it, basically. You can't write out exactly what it is. It's a decimal that keeps going forever. It never repeats. It never stops. That's irrational. The other numbers are called rational numbers. They could be written as a ratio. So if they're a decimal, then they stop, or they have a pattern, or they have some way, then we can write them as a fraction, like 1/3. 1/3 would be 0.3 repeating. It's repeating. It's rational, though, because it repeats. This has no pattern. Does not repeat. Okay, so backing up a little bit, let's talk about where square roots come from, and talk a little more about what it is they're asking. Okay, so the first thing is, if I have a square right here, and each side is 10, right? The area would be 10 squared. The area would be 10 times 10. The area would be 100, right? So if I was asking what's the square root of 100, what it's really asking is, hey, I've got a square like right here. I don't know how long the sides are, but I know the area is 10. So how long would each side be? That's what this is asking. If I know the square has an area of 100, sorry, I misspoke. If I had a square and I knew the area was 100, this right here is asking how long is each side. So in other words, what number times itself is 100? And it's 10. Not too difficult there, but again with our 11, if I had a square whose area was 11, how long is each side? That's a little tougher to answer. That's an irrational number. We just leave it just like that. So anyway, let's talk a little bit more about square roots and how to simplify them. So the thing with square roots is when you're simplifying square roots, you're looking for perfect squares. So let's say I had the square root of 24, right? This is asking what squared is 24. What squared is the radicand? That's what it asks. Now, I've got my list of perfect squares that we did earlier. 25 is a perfect square and 16 is a perfect square. 24 is not. So what you have to do is to answer the question, what you got to do is you got to factor. But you're not doing prime factorizations. Don't do prime factorizations because the question has nothing to do with primes. The question has to do with squared numbers. So what you're going to do is you're going to factor and you're going to look for the biggest perfect square. Now, that can take a little time because you might be used to looking for prime numbers. But if you think about this, like 24, you could start off with 2 times 12, but there's no perfect square. You could start off with 3 times 8, no perfect square. But 4 times 6 does have a perfect square. See? So 24, the square root of 24 would be 4. The square root of 4 times the square root of 6. You could separate it like this. Now we know what this equals. The number times itself that is 4, well, that's just 2. Now, 6, you know 6 is 2 times 3. Those are both prime numbers. We can't do much with the square root of 2. We can't do much with the square root of 3. We can't simplify them, so we're just going to put them together and leave it just like this. This is the number times itself that equals 24. Now, for the sake of time, I'm going to plug that into a calculator and show you that it's true. I'll show you how to multiply square roots and stuff together in a future video. So here's what I got. I'm going to put parentheses. I'm going to go 2 times the square root of 6. Right? There we go. And I'm going to close the parentheses. All right? Now, it looks like a lot of parentheses, but let's make sure we got it right. I got 1 to group this whole thing together because I'm going to square it. I'm going to multiply all that together. And then times the square root of 6. So square root of 6, and then there's the second parentheses for the square root, and this parentheses here closes that group together. Now I'm going to square it. Okay? Equals 24. This is the number right here, times itself, that equals 24. This is the answer to the question, what squared is 24? So again, we're not going to do any more examples on this video. I'll do another video in the future where we do a bunch of examples, but square roots ask a question. Square roots ask, what number squared is the radicand? The number inside. What number times itself equals that number? That's what you're trying to answer. If the radicand is not a perfect square, then what you have to do is you have to factor looking for the biggest perfect square. So we will do one more example. Square root of 50. You could do 5 times 10, no perfect squares. Or you could do 2 times 25. Do you see? Perfect square right there. So the square root of 50 would be 2 times the square root of 25. Right? Now, this number, square root of 2, it's irrational. Can't do anything with it. It's going to stay just like that. But this number, that number right there is 5. 5 squared is 25. The answer to the question, what squared is 25? Well, that's just 5. Okay, now, that's an acceptable answer, but it gets confusing. A lot of the time, it looks like the square root of 25. So the way we do it is we put the rational number in front and the irrational number behind it. And that's okay. You can change the order you multiply. Like 3 times 7 is the same exact thing as 7 times 3, so we can switch around the order. So anyway, this number times itself is 50. You don't have to take my word for it for now. I'll show you how to check that again in the future. But, so, square roots, what number squared is the radicand? To figure it out, you factor the radicand, looking for the biggest perfect square, writing all your work out nice and neat. Don't skip, don't just write the numbers, write the square roots. And then you're taking the square root of that perfect square. And then just put it in order, and you're done. Hope this video was helpful. If you have questions, leave them in the comments box. If you found the video helpful, please click like. And as always, please subscribe. Have a good day.